Hello everyone. In our last class, we started we were doing the topic correlation. Let's have a quick revision of that, and then we'll move to the second part of the chapter, that is regression. So in correlation, we only talk about bivariate data. Bivariate means any data which has two variables. From a bivariate data, we can construct marginal and conditional distributions. So if I have a P by Q classification bivariate data, how many marginal distributions are possible?
Two.
Two. How many conditional are possible?
P plus Q.
P plus Q. How many cells or entries are there?
P into Q.
P into Q. Then we move to actual correlation. What does correlation give us?
Relationship between the two variables.
Association or lack of association between the variable, whether they are related or not. Nature and extent of correlation. It does not form the mathematical relation and hence does not help us to find the value of one variable when the value of other is provided. Now, the correlation coefficient is denoted by
R.
the value is the value of R. What is the range of the value of R?
Minus 1 and 1.
Minus 1 to plus 1, both included. Then we have change of origin and scale. How is it affected?
In factor.
Only the scale factor. What we are concerned is only what is multiplied, the sign of the number that is multiplied and divided with x, right? So if I tell you that R xy is 0.3, 3x plus 2u equal to 5, 5x minus 2, 5y minus 2b equal to 7. What will be R u v?
Minus 0.3.
If you isolate your u, 5 minus 3x by 2. Here if I isolate v, 5y minus 7 by 2. Here x is multiplied by a negative number. Here x is multiplied by a negative number, right? And here y is multiplied by a positive number. So the sign of the r will change and it will become minus 0.3. Is it okay? If I give you only one equation between x and y, how do you find r? How do you find r? If there is only one relation between x and y, which is a linear equation, so r is going to be either plus 1 or r is going to be minus 1. What we do is isolate any one variable, whatever you feel like. The coefficient of y is a negative number, so the value of r will be minus 1. If the coefficient would have been positive, then the value of r also would have been positive, plus 1. Is it understood?
Yes.
Everybody clear?
Yes, ma'am.
Then we move to measures of correlation. How many measures of correlation are there?
4, ma'am. 4.
First one is scatterdike. Out of all the four, which one will be used for a linear relationship? Carl Pearson product moment. Which one will be used for qualitative characteristics?
Spearman's correlation.
Spearman's rank correlation. Which one is not affected by the magnitude of the observations? That is concurrent. We only use plus sign and minus sign. I'm not bothered whether the number is 23 or 24. If it is larger than the previous number, I'm only concerned with plus. How much larger, I don't care, right? So we are not actually concerned with the magnitude of the observation. That is concurrent deviation. Is it understood?
Yes.
If the values of the observations are uniformly distributed, then R is if the values of the correlation are uniformly distributed, then the value of R will be R will be 0. If the values are uniformly distributed, then the value of R is 0. Okay? Is it understood?
Yes.
What happens if the values of the observation move from upper left to lower right?
Negative.
Negative. Upper left to lower right in a straight line.
Perfect. -1.
Perfect negative, R will be -1. Yes. If it moves from lower left to upper right, it's a positive correlation. If it moves from a lower left to upper right in a straight line, it is a perfect positive correlation. Clear?
Yes, ma'am.
Okay. Then now what we are going to talk about is the regression. So what were the two drawbacks of correlation? That it does not form a mathematical relation between x and y, and it does not help us to find the value of one when the value of other is given. That is the job of regression. So what will regression do is it will form a equation between x and y, and then with that help of equation, with the help of that equation, we'll be able to find x when y is given, and we'll be able to find y when x is given. That is the job of regression. In our syllabus, we're only going to talk about linear regression. That means we will only find linear equations. We are only going to find linear equations. The method by which we find that equation is known as method of least squares. So what does it do is, like in correlation, the question will look like what? I will give you certain values of x, I'll give you certain values of y. If I plot them, okay. So what this method of least square does is, it helps us to find the line of best fit. It helps us to find the line of best fit. What do I mean is, there are several lines that we can take here, but only one of the line will be known as the line of best fit. Which line will be that? The line through which the error or residue, basically the deviation, is minimum. So this is the actual value. The line says the value is this. So this is your observed value and this is your expected value. The difference between these two, which we also used to call as deviation, is now known as error or residue. Error or residue. So what does this line does is, the line of best fit is decided by two conditions. First, the error should be minimum, and the errors, when I add them, should give you 0. And when I find the square of the error, it should give you the minimum value. These two conditions, when they are satisfied, that particular line is known as the line of best fit. The method through which we find this is known as the method of least squares. So this method, we won't use this method, we'll directly have a formula. So this method helps us to find out the line of best fit, or the regression line, through which we will be able to find one variable when the value of other will be given. Is it understood till here?
Yes, ma'am.
Okay. Now, see, there are two possibilities. First, y may be given and you have to find out x. And the second is x may be given, you need to find out y. There are two possibilities. Right? So this is x here and this is y. This is y on x. That means x will be given. So this will be known as your independent variable. Y we have to find will be known as dependent variable. So the diagram that I have drawn is the line of best fit for y on x. We are finding y when x is provided to us. In that, what we do is we minimize vertical distances. See, the error or residues are vertical. So here what we do is we minimize vertical distances. We minimize vertical distances. And if it will be x on y, the line will be x on y, that means x on y, that means y is going to be given. We will be finding out x. Y will be independent, x will be dependent. In that case, we'll be minimizing the horizontal distances. So here there will be two lines of regression. One line is y on x, and the other will be x on y. One of the line will be y on x, the regression line of y on x, and another line will be x on y. The same formulas are not used, right? There is one equation that will be y on x, and there will be a separate equation for x on y. So depending upon what you need to find, according to that, we'll be finding out the equation. If x is given to us, then I've asked us to find y, we'll be finding out the equation of y on x. If y is given to us and we have to find out x, we'll find the regression line of x on y. So there are two regression lines. One is y on x, other is x on y. Both are obtained using the method of least square, where we minimize the error or the residue. What is error or residue? The difference between the observed value and the expected value. In case of y on x, we minimize the vertical distance. In case of x on y, we minimize the horizontal distance. Both these lines are also known as the line of best fit. Till here, any doubt?
No, ma'am.
Let us write
No,
from
ma'am.
first. Regression. First. Helps to find a mathematical relation, between x and y. Helps to find the value of one variable when the value of other is given. The equations, also known as line of best fit, is obtained by method of least squares. Method of least squares, in which we minimize the error or residue. What is error or residue? Observed value minus expected value. Difference between observed value and expected value. We only study linear regression. There are two lines of regressions. First, y on x, where x is given, hence independent variable. Y we have to find. So, dependent variable. Obtained by minimizing vertical distances in scatter diagram. Second is x on y. X on y. In this case, which one will be independent variable?
Y is independent.
Y will be given, so independent. X we have to find, so dependent. And this will be obtained by minimizing the horizontal distances in the scatter diagram. Horizontal distances in the scatter diagram. Six. How many correlation coefficient or correlation parameter was there? Only one, which was R. There was only one correlation coefficient. There was only one correlation parameter. But in regression, there are two regression coefficients or parameter, whatever they say. Byx, that is for y on x, the parameter, and bxy. There is only one correlation parameter, there is only one correlation coefficient, but there are two regression parameters or two regression coefficients. Clear?
Yes, ma'am.
Now we'll move to formula. What I'm about to start, it doesn't come in exam. Okay? It usually be, you'll see, because the length is so much, even if it comes, you won't be able to complete. It's a huge sum. Okay, so there are the mainly the portion that actually comes and every time comes is the property section. But since you'll open the book and you'll see that there are so many formulas, for that I'll teach you, but it's not the important section. Just remember the formulas in case the formula itself comes, but actual sum, it's way too long. So it's not possible for you to complete that sum. Okay, can I remove this?
Yes, ma'am.
Okay, so first, regression line of y on x. First, normal equations are, the number one is only theory, we don't use in the equation from which the formula is obtained. Summation y na plus b summation x summation xy a summation x plus b summation x square. From here, the formulas are derived. What is the actual formula? The line of best fit is, the formula is y is equal to a plus bx, where b is equal to byx, because you are talking about y on x now. So the parameter b is byx. It is also the slope of line y on x. The formula is covariance by standard deviation of x squared. That means variance of x, or R standard deviation of y by standard deviation of x. Both, depending upon what is given to you, you find accordingly. If they give you R, you'll use the second formula. If they've given you only the data, you use the covariance formula. There is one more formula, and A is y bar minus bx bar. B and byx are same thing. So for this, we have to do a lot of things. And then we put these values in this particular equation. Y is equal to a plus b. It's where x and y are variable. A and b value we will obtain and put it here. Once you get this equation, then what you do is, you have been given x, you will be finding out y. So if x is provided and you have to find out y, this is what you will use. There is another formula, third. Another formula. for line of best fit y on x, y on x, y minus y bar, standard deviation of y, कौन सा नहीं अभी से r x minus x bar, standard deviation of r will be written which is independent variable on that side. R will be written on the side where x is given. Right till here. Done till here? Okay. Then regression line, another formula for x on y. X on y. Number one, the normal equations are summation x equal NA B summation y, summation xy, A summation y plus B summation y square. We don't use this. Second, the equation for line of best fit. X on y is x is equal to a plus by, where b is same as bxy, which is also the slope of x on y. Formula covariance by variance of y, or r standard deviation of x by standard deviation of y, and a is x bar minus by bar. Third, another formula. This is same y minus x y bar by standard deviation of y, x minus x bar standard deviation of x. You use r on the side of independent variable. So y was written, so r comes this side. Is it done? Now we'll use all the formulas. But if this question comes, form the line, we will never attempt. There is another trick that in some question is applicable. I'll teach you when we'll be doing the sums, but I need to teach you at least once this sum. But on my personal advice, even if it comes, never attempt. It's not possible. It takes too much of time. We don't have that much of time. Is it done?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Question. X and Y like correlation, it will be given 2, 4, 5, 5, 8, 10. Y is 6, 7, 9, 10, 12, 12. Same like correlation n, summation x, summation y, summation x square, summation y square, summation xy. Find everything. So n, there are 6 observations. What is summation x?
34.
Summation y?
56.
56.
Summation x square?
234.
234. Summation y square?
554.
xy? Summation xy?
351.
Let's wait a minute. Let everyone complete. Okay, let's calculate mean of x. Summation x by n. 5.667. Y bar?
9.334.
No, it
5.3.
doesn't become 4. If it is more than 5, then it increases. If it is less than 5, it just gets ignored.
Okay. Yes, ma'am.
Till here, everyone done?
Yes, ma'am.
Okay, now let's calculate covariance. Summation xy by n minus x bar y bar. So 351 by 6 minus 5.667 into 9.333.
5.60.
5.6098. Does it match?
Yes, ma'am.
Okay. Standard deviation of x square. Variance basically. Summation x square by n minus x bar square. 234 by 6 minus 5.667 whole square.
6.88.
6.885. Then variance of y. Summation y square by n minus y bar square.
5.228.
Hmm.
5.2.
Done? Okay.
Yes.
Now we will first find y on x. So b or byx was covariance of x by variance of x. So covariance was 5.6098 divided by 6.885. Answer.
Zero point
0.814.
And A. Formula was y bar minus bx bar. Y bar 9.333 minus b.8147 into x bar was 5.667. Answer.
4.716.
0.7.
So equation will be y equal a plus bx y 4.716 plus 0.814x. That is the final answer. Now, if they give you the value of x, put here and then you will get the value of y. Any doubt here?
No, ma'am.
No, ma'am.
If we have to calculate x on y, only one of them will be asked. So we first calculate bxy, covariance of x by variance of y. So 5.6098 by 5.228.
Ma'am, 1.073.
0.073.
Then a x bar minus b y bar, x bar 5.667 minus 1.073 into 9.333. Negative नहीं है?
Yes, ma'am.
minus
Minus
4.34.
4.347. So equation will be x equal a plus by. So x is minus 4.347 plus 1.073 into y. Any doubt?
No, ma'am.
So this is one of the method. Everybody clear?
Yes,
Yes,
ma'am.
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 Okay. There was another formula that I gave you. Let's try that question. X is 80, 75, 76, 69, 70, 85, 72, 68. Y 85, 65, 72, 68, 67, 88, 80, 70. Calculate everything. Number of observation is calculate everything. Summation x,
595.
595.
summation y,
595.
summation x square,
44495.
sorry,
44495.
summation y square,
44791.
4, 4,
791.
summation x square is correct.
44495, ma'am.
What is summation xy?
44, 529.
529.
Now, first calculate mean of x and y. They will be same only. 595 by 8.
74.37.
Okay. Standard deviation of x. Answer.
Five point four nine.
5.498. Standard deviation of y.
Eight point one nine.
8.19.
Then we want r. We want r. For that, we will need first covariance. Answer.
34.48.
34.484. So, line y on x. Formula was y minus y bar standard deviation of y r x minus x bar standard deviation of x. So, y minus 74.375 by 8.1996. Okay, we didn't calculate R. R is covariance by product of standard deviation. Answer.
0.765.
0.765.
X minus x bar divided by standard deviation of x. If they ask us x on y, same thing, only r comes this side. Zero 0.765. Got the answer?
Yes, ma'am.
Hmm? Guys got the answer?
Yes, ma'am.
Yes, ma'am.
Okay, question. X is 8, 10, 10, 12, 15. Y is 18, 20, 22, 25, 28. Use the first method and tell me what is y on x equation and what is the equation of x on y. Calculate. What is the value of n? Number of observations are 5. Summation x should be 55. Summation y should be 113. Summation x square 633. Summation xy 1284. What is summation y square?
2617.
2617.
Okay. The first is byx. What is the value of byx?
0.261.
No.
Ma'am, 1.46.
1.4642.
Very good. What is a? Okay. Check your covariance should be 8.2. Did you get it?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Variance of x is 5.6.
Yes, ma'am.
Variance of y is 12.64. So Vyx is covariance by variance of x. So 8.2 divided by 5.6, 1.464. Then A is y bar minus B x bar. How much? 6.498.
0.496.
So y on x will be y mine equal 6.4928 plus b 1.464x. Did you all get this? Guys, did you all get it?
Yes, ma'am.
Bxy. Covariance by variance of y. So 8.2 divided by 12.64. 0.6487 x bar minus by bar. How much?
Minus 3.669.
66139. So equation will be x equal a plus by. All of you got the answer? All of you got the answer.
Yes, ma'am.
Any doubts still here?
No.
Uh, that's it for today.